So in these types of algebra problems on the GRE, where you're given only one equation with two variables, you should always try to see if that you could somehow relate it to this expression. We can't really find the values for A or B, but we can somehow manipulate this. So I'm going to use some exponent rules to rewrite this. A squared to the third would be a to the sixth, multiplying those exponents, and b cubed to the 4 would be b to the 12. So this expression is equivalent to a to the 6th times b to the 12. Now this is same as, and the key is I need to somehow relate to this expression. And if I actually multiply both sides by b squared, this is ab squared equal to 2. So you have to keep an eye on this expression and see how that could be related here. And notice that b to the 12 is b squared to the 6th. And so this is really a times b squared to the 6th. So I'm using this exponent rule in reverse, meaning if I have, I'm going to use different variables, x to the m times y to the m, this is the same as x times y to the m. And that's sort of what I'm doing here. You can think of a and b squared both raised to the power of 6. So this is a times b squared to the 6th, and this would be then, and we know the value of a times b squared. So it's hard to know with these types of problems whether you'd be able to isolate the value for that expression or not. Sometimes you may, sometimes you may not. So that's why you have to do this work. So this becomes 2 to the 6th. So we can actually compute this. Powers of 2, I think it's good to know the smaller values. 2 to the 4 is 16, 2 to the 5 is 32, and 2 to the 6 is 64. So quantity A is actually 64. And here the answer would be they're both equal. That would be C. So again, with these types of problems, don't assume that just because you have only one equation that you won't be able to necessarily find the value of this expression. Now I want to show two other ways of doing the same problem. The second approach is what I call substitution. So you take one of the variables and you substitute into this expression and simplify it, and if it is if it's supposed to be a unique value or a number, then it should come up to that value. So what we're going to do is to replace either A or B. It's easier to replace A in terms of B. So again, I'm going to first use the exponent rule as I did earlier, a to the 6th, b to the 12. Now I'm going to replace A, which is 2 over b squared to the 6th. In fact, this method is actually easier, but it's hard to know. In some problems, manipulation is necessary, so that's why I presented that first. So here again, I'm going to raise each numerator and denominator by 6, and so this becomes 2 to the 6th, and then the denominator becomes b to the 12 because I'm going to multiply those two exponents. These two cancel out. Again, I left with 2 to the 6th, which is 64. So we got the same answer. And the third approach is using numbers. I mean, you could say b is 1. In that case, a would be 2. You compute this expression. So it would be 2 squared to the cube, 1 cubed to the 4. This is just going to be 1. That again becomes 2 to the 6th. That's 64. Now, that's only one value. If you're using numbers, you have to use at least 2. So I could use, let's say, what would be a good value? B is equal to 2. In that case, A would be half. But you can see if the exponents were really large, it would be tedious. It would not just be a power of 2. So here this would be half squared to the cube, and b cubed, this would be 2 cubed to the 4th. This becomes 1 over 2 squared. So I'm going to leave it in powers of 2, and this becomes 2 to the 12. That becomes 1 over 2 to the 6, 2 to the 12. I subtract the exponents, and that becomes 2 to the 6, which is 64 again. So if you're using numbers, you have to take this route. You have to pick some nice numbers. And also you need at least two examples. If you just use one, if you're pressed for time and it's equal, perhaps you can take a chance and say they're equal. But in general, if you want to be certain, at least 2. So just to recap, the correct answer here is C.